Hello students, how are you all? So, today we are back. Today we are going to start rectilinear figures, but according to reduced syllabus, there are some restrictions that you can see. There are 1, 2, 3, 4, 5, 6 proofs are there, where only 4 proofs we have to perform and rest of 2 we have to do only applications. So I gave you 4 proof over here one by one. Let's see. First proof is that both pair of opposite angles is equal. So that must be for a parallelogram, or you can say that must be for a quadrilateral. So for here you can say it is how we have to prove this one. First of all, if you notice this one, how I provide it over here, that is what is given. First of all, you have to take one parallelogram, that is ABCD is a parallelogram, where AC is the diagonal. Right now, what we have to prove? We have to prove that A is equal to C, that angles, and D angle is equal to angle B. That means the opposite angles are equal. Alright, so moving to the proof right now. Alright, so what is the given thing? The main thing is that as this is parallelogram, so we can say the opposite sides are equal. And that is gonna help us to build the idea of alternative angle. Let me discuss the alternative angle first to those who have confusion in that. If two parallel lines cross by one single straight line, then you can say that this angle is should be equal to this. Why? Because these are alternative angles. Acha, how you will find that what should be the alternative angle and how it should look like? You should always find either N pattern or Z pattern. As you can see over here, this angle is equal to this. So these are alternative angles. So this is pattern Z, and in this case these angles are alternative angles, so this is pattern N. So that is very basic thing, we know that. Still I just explain it once. Okay, now coming to our main proof, as AB is parallel to DC. So AB is parallel to DC. So this diagonal AC, cutting that into two equal sides, that means they are creating Z pattern. So while you have that Z pattern, this angle should be equal to this. That is why angle BAC is equal to angle DCA, as you can see, due to this alternative angles. Okay, I think the idea is clear right now. Now moving to the next one, that is also if you see these two sides, they are parallel, and in this case you are having this opposite N pattern. So these two angles should be equal, that is why the DAC angle must be equal to BCA. Alright, so we have the alternative angles right now. All we have to do, we have to add equation 1 with equation 2. That is what you will get, BAC plus DAC is equal to DCA plus BCA by putting that one. Now think again. BAC, that is this one, is added with DAC, that is this one. So that whole is nothing but the angle A, or you can say it is angle BAD. So as it is over here. Similarly, if you look for the other side, it is DCA plus BCA. So again the same thing, total angle. So the angle is DCB. I hope the idea is clear right now. You got that opposite angles are equal to each other, and that what we have to prove over here. Hence it is proved. Alright. So the first thing is done. Now moving to the second one. Before that, let me show you. We just did this one. Both pair of opposite angles are equal. Now moving to diagonal bisect each other and bisect the parallelogram. Alright. So all we have to do about the diagonals. Coming to this coming to this theorem, the diagonals of parallelogram bisect each other. That all we have to prove over here. So what is given? Again the thing, that is a parallelogram ABCD where we have the diagonals, that is AC and DB. And also remember, we just proved that the opposite angles should be equal, but still we will show it again over here. Alright, so what we have to prove? That OC, that means the half of the diagonal, which must be equal to OA, and also OB must be equal to OD. That all we have to prove over here. That is how we can actually say the half of the diagonals are equal to each other in both sides. So as you can see over here, the same process, as the two sides are parallel, so the diagonal will cut that and we will get two alternative angles. You can check all these two alternative angles, that how they are making either Z or N pattern. Okay, so we just discussed it. Right now coming to the idea. All we have, this angle should be equal to this, and this angle should be equal to this. And what is this? This is vertically opposite angle, so they are must be equal to each other. So you can say these two triangles are totally same according to ASA congruency, angle side angle. Alright, so that means the sides should be equal to each other. We know, we learned the congruency method, and this side should be equal to this. And that is how by simplicity you can say that these sides are equal. Alright, so we just learned this one. Now coming to the third proof of today, that is rhombus as a spatial parallelogram whose diagonals meet at right angles. Alright, so here the proof, so that if the diagonals of quadrilateral bisects each other at right angles, then it is rhombus. Obviously the same thing. Okay, so first of all, what is the spatial property of rhombus? That all the sides must be same. Okay, so what we have over here, that ABCD is a quadrilateral where diagonal bisects each other. So as the diagonals bisects each other from the last theorem, we can say this is equal to this and this side is equal to this. Okay, as it is written over there, OA equal to OC, OB equal to OD. Alright, also what should be there, that is we have to take this all sides are, or sorry, this all angles are right angle, because we have to assume that it is a diagonal and they are cutting them in right angle. If they are doing so, we have to prove right now it is a rhombus. I gave you two type of methods over here, so no issue with that. You can use any one of those. I'm just explaining the first one. Now how to prove? We assuming that ABCD is a rhombus, we have to prove that. Acha. Now prove. Coming to rhombus is a parallelogram with all sides equal, and we first prove that ABCD is a parallelogram. Then we will come to that equal part. Okay, so let's start. As you can see in our last proof, we already built two triangles over there, and those are similar triangles. We proved by congruency in the last proof. And also we are using that kind of technique over here, that as you can see, this two sides OA is equal to OC and also OD is equal to OB. Yes, I'm just marking it. Please check it by yourself. It will be better. Okay. So all we have. And one more thing is there, that is the vertically opposite angle. AOD angle must be equal to COP. Acha, one more thing over here, it is not written over here vertically opposite angle, so you should write it in your exam. Remember that. So just correct it. Okay, so we got the idea that which are equal to what. Now, as you can see that by SAS congruency, we can say these two triangles are congruent to each other. That means the angles OAD and the angle OCB, these two angles, those are also equal to each other. Also, you can think about the alternative angles as they are making this pattern. So we can say these two angles are equal to each other. That is what they are doing over there. Acha, we got the idea right now. So for the side A and B with transversal AC, we can say that these two are alternative angle as I told you right now. Acha. So coming to now parallelogram part. As we know, those two are alternative angles, so we must sure that it is parallel to each other. These sides are parallel to each other. So whenever we got these sides are parallel to each other, that means we have those as parallelogram. So one thing is completed, that we have proved it is a parallelogram. Now it's time for we have to prove it is a rhombus. So all we need ABCD as a rhombus. What we have to do for that? We have to prove that all the sides are equal. I told you for rhombus all the sides are equal. So if we prove that, then it will be a rhombus proved automatically. Alright, let's do that. So we already have OA equal to OC and OD equal to OD as the common side. I'm talking about this one and this two. So by that you can say that by SAS congruency we have these two triangle, that means AOD. I'm talking about this and this. These two triangles are equal. So they are congruent to each other. We got the idea. I'm repeating, I'm talking about this and this triangle only. They are congruent to each other and the proofs or the reasons are given. So by proving the congruency, we can say that AD should be equal to CD. So this is equal to this and nothing else we have to prove. We already proved once that this is equal to this and this equal to this. So if AD is equal to BC, we already proved that earlier, and AB is equal to CD. These two are already proved. Right now we just prove that AD equal to DC, and that means all these sides are equal to each other. So this is the proof of rhombus. That means we can say this kind of spatial parallelogram is nothing but rhombus, where all the sides of that parallelogram should be equal. That is the main reason behind it. Remember that. So this one is completed. Finally, in a rectangle, diagonals are equal. In a square, they are equal and meet at the right angle. So that is very simple over here. So coming to the last one, that is we have to prove it for the rectangle right now. What is given as well as the ABCD is a parallelogram given where AC equal to BD, that is a rectangle. What we have to prove over here? That this is a rectangle. So for that, I just divided this one in few triangles, that is ABC and DCB. So after doing that, you can see that AB must be equal to DC. BC and BC is the common side obviously, and AC must be equal to DB, and that is given one. Okay. So this is enough to make those two triangles in SSS congruency as congruent. So we have those triangles as congruent one. That means we can say that ABC is equal to DCB. Alright, let me show you the angle once. That ABC, this angle should be equal to DCB, this angle. Remember that. As we just proved those two are congruent triangles, so we can say that also by simplicity. Okay. So we know that if we add these two angles, they will be each 90. So total will be 180. So we just did that, and also we know that this angle B should be equal to this angle C. We just proved it in our last step. So that is why we can say 2b equal to 180, that means b equal to 90. And once you prove that one angle is 90 over there, you can show that this is opposite angle, this should be also 90. So if if two angles are 90, so already half part is done. And also we prove that these two are congruent to each other, that means all the sides are 90. So you can say it is a rectangle. So one part is done. Coming to the next part for the square, what we have to prove, let me show you. Show that the diagonals of square are equal and bisect each other at right angles. Okay. So as well as ABCD is a square, we just take it where diagonal intersect each other at O. Right now, we have two triangles, just like the rectangle one. So what we will get from there, AB equal to DC and also ABC equal to DCB angle. And one more thing, that is the common side BC equal to BC, and these three are enough to prove that we have congruent triangles by SAS. Alright, so right now all you have to prove over here, each of the triangles are congruent to each other by same method. Also in next step, these two. So while you will have all the triangles are congruent to each other and the side should be 90, then you can say that it is nothing but the square. So that's it for today. If you have any doubt, don't forget to write it in the comment section and in the group. So till then, thank you for watching and we will meet in the next video.